Hello everybody. Today we're going to go ahead and start working on chapter 11. Our first lesson today is about circumference and arc length. Circumference is something that you've definitely heard of before and probably worked with before. The circumference is just defined as the distance around the circle. We have two formulas to find the circumference, and it's based off of what is given to us. Our first formula is 2 times pi times r being the radius. So that's our first formula. The other option is I could be given the diameter instead of the radius. So my circumference formula then would just be the pi times the diameter. So whenever we're given a question involving circumference, it's important for us to figure out, are we using our radius or are we using the diameter? So to find the circumference of a circle with a radius of 9 centimeters, we need to plug into our circumference formula that uses radius. So this would be 2 times pi times r, which is 9. You can go ahead and plug this into your calculator. Every calculator does have a pi button. If you're using one of the graphing calculators, it's just it's second and the exponent button, the button above your division symbol. When I plug that in, today we're going to round two numbers after the decimal place. That's what your Big Ideas assignment is going to ask you to do. So this is 56.55 centimeters. And it's just centimeters. Circumference is just an extension of perimeter. So it would not be squared. That would be area, which we'll do later in this chapter. So on the next slide, we're given 3 questions where we're asked something different about the circle on each of these. We need to use the formulas we know involving circumference to work backwards and find the missing piece. So on A, we have the radius of a circle. We want to find the radius of a circle that has a circumference of 26 pi. Since we're using the radius, we'll use our radius formula, or the radius circumference formula, which is 2 pi r. I want to get r by itself, so I can do that by dividing by both 2 and pi on both sides. So we'll cancel on the left side, on the right side, and then on the left side, my pi's will just go ahead and cancel. And I'm left with just 26 divided by 2, which would be radius equals 13. Part B, we're asked to find the diameter of a circle with a circumference of 17 feet. So 17 feet is our circumference that we're working with. And the diameter formula is just pi times the diameter. So in this instance, I only have to divide by pi to get the diameter alone. We'll do it on both sides. If you're wondering why on question A we did not just multiply 26 times pi at the start, you can and you will get the right answer. But if your question gave you pi and you know you eventually will be dividing by pi, it would make more sense to leave it alone, so that way we can cancel it out. But here 17 is just the circumference. It doesn't give us pi. So here we're going to have to throw in our calculator, and we're probably going to have to round. So our diameter equals 17 divided by pi, which is, again, we're going to 2 decimal places, 5.41 feet. Last question on this page, we have the circumference. We want to find the circumference of a circle, and we're given the equation of this circle. So the equation gives us 2 things. It gives us the center with these numbers here, which does not really help us with the equation of the circumference. The circumference has no bearing on where the circle is. It's just how big is it. So what we need to use is this part of our equation here. Remember, on the equation of a circle, this is r squared. which means r would just be the square root of 81, which is 9. Go ahead and we will plug in our formula here, 2 pi r. Again, we're using this formula because we were given the radius. And this is a question to just plug straight into the calculator, which gives me 56.5. And we're going to round to 5. There's not a unit here, so we can just leave it as the number as is. Our circumference will be 56.55. On the next slide, we're going to start talking about arc lengths. We've talked about arc length so far in talking about the measure. If you see a question asked about or talk about the measure of an arc, we're measuring in degrees. If the question asks us about the length, though, when we measure length, I don't measure length in degrees. I measure length in units. So this could be inches, feet, centimeters. Any of the units that we've used for length can apply here when we're finding the length of the arc. So we can find the measure of the arc, or we can find the length. So it's important to see what is the question asking you to do. So to find the arc length, we're going to be using proportions. It's been a couple chapters since we've used them, but what this is going to look like is we will compare the ratio of the length of the arc, so the length of AB, over their circumference, so 2 pi r. So the ratio from the arc length to the circumference is equal to the measure of the arc AB compared to the whole circle. The whole circle we know is 360 degrees. When you set up a ratio like this, our circumference formula and our 360 degrees, those are not going to change. Those numbers are going to stay right there. What we are going to be changing is, from question to question, what is the length of the arc and what is the measure of the arc. So make sure you have this written down in your notes so you can come back to it. This is definitely going to be a calculator heavy lesson. So let's go ahead and practice these, and then we'll be just about done with notes for today. So we want to find the indicated measure. The indicated measure here is the length. It's important that we're seeing this is about length of AB. So let's start with our length ratio. We want to find AB. That's the one we don't know. Over the circumference. The equation for our circumference needs another value. Fortunately, they gave us our radius right here is 8. So our circumference, always 2 pi, and we will go ahead and put in our 8 as our radius. Next, we want to find the ratio of the arc measure and the circle measure, which we know the circle measure is going to be 360 degrees because every circle is 360 degrees. That's what makes it a circle. And I know the length of this arc comes from my central angle. The angle and the arc are the exact same measure. So our arc measure is 60 degrees. From here we can cross multiply. So we can go this way and this way. So we have whatever 360 times AB is has to equal 60 times the circumference. This is absolutely just something to throw in your calculator. 2 pi 8 times 60 gives me 3015.9. We'll round to 3. Then our only step from here would be get AB by itself. We'll divide by 360 degrees on both sides. So I'm left with 360 cancels. I'm left with the length of AB equals 3015.93 divided by 360. This is 8.38. And then our unit was centimeters. So the length of that arc, the distance from A to B, is the length of 8.38 centimeters. Our next slide is asking us to find the circumference of Z. So we have two things here. We know what the arc measure is. The arc measure comes from our central angle. It's just the same. It's 40. And we know what the arc length is. The arc length is 4.19 inches. If you don't know how to tell which one's which, whichever one uses a unit like inches, that's going to be your length. So let's set up our ratio. The arc length is 4.19 over the circumference. We don't know what r is. We know we can find it though with 2 pi r. This equals our arc measure, 40 degrees, over 360 degrees. Once again, cross multiply. So we will have 4.19 times 360, which is 1,508.4 even, times 40 times 2 pi r. So 40 times 2 is 80. We'll say 80 pi r. We want to get r by itself. That's the only missing piece we have of our circumference. So to do that, let's go ahead and divide by 80 pi on both sides. So that completely gets it off of the right side. And then 1508.4 you can divide by 80 pi. Sorry. Divide by 80 pi. Sorry about that. Which gets us r equals 6.0017, so we can say 6.0 since we're rounding 2 decimal points. However, we did not find the circumference yet. We've only found the radius, which was the only missing piece we had, right? This is our radius. So we need to go back into our circumference formula. 2 times pi times 6. This is what our circumference is going to be, which would be 12 pi. 12 pi comes out to, when we put in our calculator, 37.699. So we'll say 0.70 inches. Our circumference is measured in length, so it would be inches. We're almost done. We got two more slides. So here we know we have a radius of 15.28, and we have the arc length of 44 meters. And we want to find the arc measure being RS. So let's set up our ratio. We start with the arc length and the circumference. So our arc length is 44 over our circumference, which is 2 times pi, times the radius, which is 15.28. This equals whatever the measure of RS is over 360 degrees. Again, that number is not going to change because our circle, doesn't matter how big or small, always measures 360 degrees. So I'm going to leave that one for you guys to finish. I want you guys to get a little practice multiplying. So if you need to pause this video, go ahead and solve it. Maybe check with the people around you, make sure you got the same answer. But I'm going to move on to the very last question. I say last question because that last slide we're not going to do today. We might talk about it together. But we're going to stop right here after this question. We have a car tire that has a diameter of 28 inches. And we want to know how many revolutions. So how many times does this tire fully rotate? So revolutions, another word for rotate. How many rotations does the tire make traveling 500 feet? The first thing we need to do, let's find the length around the tire. So here's our tire. And I know that the diameter is 28 inches. So the actual circumference would just be we have diameter, so it would just be pi times diameter, which is 28. Which is 28 pi in your calculator, 87.96 inches. We know our circumference now. Before I can compare to the question of how many rotations were in 500 feet, I need to convert to the same units. So we have 500 feet here, but I want to be in the same unit, so we'll make it in inches. Well, there's 12 inches in a foot, so for 500 feet, we would just do 500 feet times 12 inches to find how many total inches there are, which would be 6,000 inches. So if I want to find on my tire here, maybe we start here, if I were to go forward and rotate all the way around, that's one rotation. Which means one rotation would cover the amount of distance my circumference is. I want to find how many times I rotated in 6,000 inches. So all we actually have to do is say if we went 6,000 inches and each rotation travels 87.96 inches, we can divide and find how many rotations there were. 6,000 divided by 87.96 would be 68.21. So that means in 500 feet, we are rotating 68.21 times to cover that distance. We're going to stop right there. You guys have a big ideas assignment today. On the big ideas assignment, your answers have to have two numbers after the decimal. Otherwise, it will count them wrong. So make sure you're including two numbers after the decimal. Make sure you're rounding correctly. But this is not a long assignment. Use your notes to help you out. I hope you all have a great day.